Kruskal-Wallis H-Test is one of the non-parametric tests. It is just like Mann-Whitney test, but actually we apply Mann-Whitney test when two samples are there, and that is an alternative of a student t-test. When we find that the data has not come from normally distributed population, then we actually apply a Mann-Whitney test. But when the number of samples are more than 2, then we can apply this Kruskal-Wallis test, and it is actually an alternative to one-way ANOVA when the normal distribution and equality of variance assumptions are not met. So this particular test is performed by considering ordinal or ranked data. So individual cases are actually ranked, and each sample must contain at least 5 observations. So if we have 3 samples, then the number of cases in each sample must not be less than 5. And the formula which is used for the calculation is very simple one. It is H, that is equal to 12 divided by capital N into N plus 1, where this capital N is actually the total number of observations of all the samples. So that is why it is denoted in capital N. So this capital N into N plus 1, and this entire figure will be multiplied with R1 square divided by N1, where this R1 stands for sum total, means rank total of sample 1. So that will be squared, and it will be divided by number of observations of that specific sample or sample 1, plus R2 square divided by N2, then R3 square divided by N3. So all such samples, their rank sum will be taken, and that will be squared, and it will be divided by the number of cases present in that particular sample, minus 3 into capital N plus 1. And here, as I just said, capital N will be equal to N1 plus N2 plus N3, means all the cases of the total samples, and R1, R2, R3 are a rank sum of different samples. We have to also find out degree of freedom, that will be k minus 1, where k stands for number of samples. So if 3 samples are there, so 3 minus 1, that will be 2. Degree of freedom in that case will be 2. And here we don't have any specific table, S table, rather we actually rely on chi-square table. So whatever H value that comes after calculation, that will be equivalent to chi-square value. So we need actually chi-square table to see the probability level at 5%. And suppose we are dealing with these 3 cases. So 3 samples are there, sample 1, sample 2, sample 3, or you can say data have been collected from 3 separate spots, and we find that we consider that it is better to rank all these individual observations. So we can prefer this Kruskal-Wallis H-Test, and the individual observations are given in these 3 samples. So what we observe, that there are total 5 cases, 1, 2, 3, 4, 5 in sample 1, and in sample 2 also luckily 5 individual cases are there, and in sample 3 5 observations are there. So N1, that is 5, N2 is 5, and N3 is also 5, and capital N will be 15, because total of N1 plus N2 plus N3, that will be 15. So here itself we can know what would be the capital N value, and that will be 15. Now our next step will be to rank all these individual values. So what we observe, that the lowest value in these 15 cases is actually 3. By perusal of this table, we come to know that the lowest value is 3. So this 3 will be ranked as 1. The next value is 4. So 4 will be ranked as 2. And the next value is 5. So but this 5 comes, you see, 2 times. So this will be ranked as 3.5. Means, let us see how this ranking will be done. Here I have shown the ranking pattern. So what we actually do, we exactly count the number of total observations, and we find that total 15 observations are there. So it's better we can write all these 15 numbers starting from 1. So 1, 2, 3, 4, 5, 6, like this. We have to write up to 15 because total 15 observations are there. And then we start seeing that which number is the lowest one. So we come to know that 3 is the lowest number. So I have written here 3. It means 3 is being ranked as 1. Then the next number is 4. It is ranked as 2. The next number is 5, but it is coming 3 times. Here 5. Then in this case also here 5 and here 5. So it is coming 3 times. So 5 is being written as 3 times, and it will be ranked as 3, 4 and 5. But we have to take average of this 3, 4, 5. That is 3 plus 4 plus 5 divided by 3, and it will come 4. So 5 will be ranked as 4. Then the next number is 7. 6 is not there at all. It is 7 and it is coming 2 times. So I am writing here 7 and 7, and it is being ranked as 6 and 7, and its average will be 6.5. Then next number is 8, and it is also coming 2 times. 8 is coming here, and 8 is also coming here in the first sample. So 8 is coming 2 times, and it is being ranked as 8 and 9, and its average will be 8.5. So 8 is being ranked as 8.5. And then the next number is 9, and 9 is coming 1, 2, then 3 and 4 times. So 9 is being ranked here as 10, 11, 12 and 13, and its average will be 11.5. So final ranking for 9 will be 11.5. And the next number is 11, and this 11 is being ranked as 14, and the last number is 12, which is ranked as 15. So we have ranked these individual observations, and in front of these observations we can write the rank value, because we actually need ordinal data, so our ranked data. So we have to write here the ranked values. So in this table you can see that 5 is being ranked as 4, 8 as 8.5, 9 as 11.5, 4 as 2, 3 as 1. So all these ranked values are written, and finally we need actually the sum of these 3 columns, or sum of the ranks of these 3 columns. So we will be writing here R1, that will be total of the ranks of the sample 1, then R2 and then R3. Now this we can see in this table that we have taken sum of the sample 1, ranks of this sample 1. So R1, that comes 27. 27 we have obtained by adding the rank values like 4 plus 8.5 plus 11.5 plus 2 plus 1. Likewise in case of sample 2, all these individual ranks have been added and the value comes 34.5. In case of sample 3, the values of these ranks are added with each other and the final value comes 58.5. So we have done major task. Now we have to simply put these values in the formula, in the H formula. So this H is equal to 12 divided by it was n into n plus 1. So this will be 15, because total 15 observations are there, into 15 plus 1, and this figure will be multiplied with 27, that is R1 square. R1 square means the sum of R1 that comes 27, so 27 its square divided by 5 because 5 individual cases are there in sample 1, plus 34.5 its square divided by 5. Here you can see in this case the R1 value is 27, R2 is 34.5, R3 is 58.5. So these three values are there, so 58.5 its square divided by 5 and minus this 3 into 15 plus 1 because here it is n plus 1. So when you will solve this entire case, you will find the value h value 5.42. It's quite simple to do it because 12 divided by 240 and then this will be multiplied with the figure obtained in this bracket, that comes 1068.3 and minus 3 into 16, that has come 48. So this final h value that has come 5.42. Now you need chi-square table to do rest of the things, and this is chi-square table. Here in chi-square table you will need actually the degree of freedom, and since 3 samples are there, so it will be 3 minus 1, that is degree of freedom will be 2. At 2 degree of freedom, the value at 5% level is 5.991. So we have to compare the calculated value with this 5.991, and what we observe that the h value that has come 5.42, and we observe through this chi-square table the value at 5% level at 2 degree of freedom, and it has come 5.991. So what we observe that our calculated value is 5.42. It is less than the table value or critical value. So we actually accept the null hypothesis. In the beginning itself we consider that the 3 samples have come from the same population, or there is no difference, significant difference among the values of the 3 samples. So what we and this we actually hypothesize in the beginning, so that becomes our null hypothesis, and the probability here, since it is more than 5%, so null hypothesis is accepted, and there is no significant difference among the 3 samples.